will have the theory of distributed database. Welcome to our 10th meeting with my lecturer, Mr. Rengga Asmara, ESCOM OCA. So in this session we have those objectives. First, to understanding the distributed DBMS and centralized DBMS, and understand the distributed architecture. Next is to understand data saving, data catalog in distributed DBMS. Next is understanding query, join, and query optimization in the distributed DBMS. And understanding how to change data, logging data in distributed DBMS. And the last is to understanding how to handle failure in distributed database. Main subject. Introduction. First is introduction, and the second is type of distributed DB database, distributed database architecture, catalog management, query, changing distributed data, and looking at distributed system. And the last is distributed recovery. What is it and how? Like what? So welcome to our lesson. The first is introduction. In the distributed databases, data is stored in multiple places or sites, if it's web, and each place is set with a DBMS, database management system, that can be run independently. The property is mainly contained in the distributed database is this two. The first is independence of distributed data. So the user does not need to know where the data is located. Development of the principle of physical and logical data independence. And the second, distributed transactions are atomic. So the user can write transactions that address and modify the data in several places, such as accessing a local transaction. So there are those two properties that contained in the distributed database. So like this. Next, for the current trend of distributed database, the user must know where the data is located. Also need to know where the system does not support the independence of distributed data and distributed atomic transaction. Both of these properties have to support the system efficiency. For distributed systems that are global, these properties may not be exact due the excessive administration in making the location of the data transparent. We have come to the type of distributed database. There are two types of distributed database. First is homogeneous. It's a system where every places to run the same type of DBMS. So we call it homogeneous. And the heterogeneous, the system whereby its different places run different DBMS, either relational DBMS or non-relational DBMS. Preview heterogeneous distributed database can be seen in the picture 7.1. Next slide is the picture. Yes, here is the picture. The database heterogeneous. So we can see that DBMS1 in the green color, DBMS2 in the red color, and DBMS3 in the chocolate color, brown color. Next subject, distributed database architecture. There are three alternative approaches to define function on different DBMS process. Two alternative architecture of DBMS distributed is client or server and collaboration server. So there are client itself, server itself of the combination, collaboration server. First, client server. Client server system has one or more client processes and one or more process server. Any client process can send a query to any process server as shown in picture 7.2. Client is responsible for the interface user, while the servers manage data and execute transactions so that a client process runs on personal computers and sends the query to a server that runs on the mainframe. So there are personal computer, PC like laptop and computer or another that user depends. So there are GUI in the client side. Here is the picture, the 7.2, the client and the main client. So user user type the query, so it will be process on client. Client is the sender, and the sender of client will send to the server. Next, this architecture became very popular for several reasons. First, the implementation is relatively simple because of the good division of functions and because centralized server. So server just one, they're central, and it's quite simple. The second, the utilization of expensive server machines are not affected on user interaction, even though the client machine is not expensive. The third, the user can run the graphical interface to GUI so that the user is more easier than the interface on the server that is not user friendly. So the server is literally have to be the experts like that. And the second is collaboration server. Client server architecture does not allow a single query to access many servers. So as the client must be able to divide a query into some subquery to be executed at different places and then divide the answer to the subquery. So the client work is quite hard because they have to be able to divide the query into some query, so there are many queries become some query or just one query. Client process is quite complex, like what I say, and overlap with the server. So the difference between the client and the server becomes clear. That's the background of the need for collaboration server. So we don't have client process really complex. That's why we need the collaboration server to make it clear. Collaboration server. In the system, there is a set of database servers which run local data transactions that cooperate to execute transactions on multiple servers, as in picture 7.3. This so so in the collaboration server, we can send a query. We can send there like that server query send server, and server can send the result to the another server. If the server receives a query that requires access to the data on another server, the system evokes subquery, execute another server, and retrieve the result together to incorporate the answer into the original query. Next subject, data saving in distributed system. We have fragmentation. Fragmentation consists of relationship that are divided into smaller fragments and sending fragments in some places. There are two kinds of fragmentation: horizontal and vertical fragmentation. In horizontal fragmentation, each fragment consists of a subset of rows from a relation of origin. And in the vertical fragmentation, each fragment consists of a subset of the column of the relation of origin. Horizontal and vertical fragmentation is illustrated in picture 7.4, like this. Here is the vertical fragmentation. So we have the T1 here, where really quite easy when we have many columns to become one fragment. And this is an example of horizontal fragmentation, that we combine many columns, but it just maybe a row or many rows. So we can just select blah 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 blah. I mean column 1, column 2, column 3, like that. And the vertical is quite simple because we have to, yeah, the column, which column or what column and what rows or how many rows, like that. The second is replication. Replication means that we keep a few copies of a relation or a fragment relation. So all of relation can be replicated in one or more places. For example, if the relation R is fragmented into R1, R2, and R3, there may be only one copy of R2, where at R1 where R2 is the replication into other places and R3 replication in all places. Like, this is the illustration. So the relation in the side A is R1 and R3, and R1 and R3, it can become replica into the R2 table in the side which can use in the side B, like that. The function of replication. So it will increase the availability of data. If a place that contains a replica of slowing down, we can find same data in another place. Similarly, if a local copy of the remote relationship is available, it's not affected by the communication channel fails. So this application is very useful. On the example, we can see that on the bank, maybe the transfer data on the bank, in the central bank and in the bank that is placed, like that is located in the many city, and it will be faster in the query evaluation. Queries can execute faster using a local copy of relation encoding to remote sites. Next subject, distributed catalog management. So catalog management, storing the data distributed at multiple places can be very complex. We need to save the data and replication how fragmented relationship, how the fragment relation are distributed to some place where the copy from the fragments and stored. The name of each replica of each fragment must exist. To provide local autonomy, use the following format: local name per site, catalog every page describing all objects. It can be fragments or replicas. Add a place and store data replicas of relationship created in the place. So catalog will be in every place. And to find the relation, see the catalog bird site. Bird site is changed but size is always changed even though the relationship never moves. Distributed query. Next subject. Distributed query. Here is the example of the relation. There are sellers and reserves. Sellers have SID that type integer, as name is the type is string, rating is integer, age is real, this date maybe, yeah. And here is the reserve, table reserve that SID is integer, PID integer, day is date, and name is string. Then do queries select if average SH from sellers as where S rating is greater than 3 and S rating is lower than 7. So we have to display the average of age from the table sellers where the rating is more than 2 and the rating is less than 7. If the horizontal fragmentation double with rating less than 5 in Shanghai is the example, and that the rating is greater than 5 in Tokyo. So we have to calculate the sum the summarize of each, and we have to count the age at both sides. If the word contains only S rating for greater than 6, so it will be easy because there is only one place. Vertical fragmentation. SID and rating on Shanghai, S name and age on the Tokyo, TID on the second place. Must reconstruct relation with the TID and then evaluate the join query. Replication. Seller copied it in both places. So here is the what is the example, still the example. Like that. So we come to the next subject, joins on distributed TBMS. Here is the example again. For example, London store 500 pages, seller and Paris have 1,000 pages reserved like this picture. Halaman is page. Next, joins operation. To handle join, the distributed TBMS should note the following. Download page as needed. In a nested loop, join in London with the outer seller and every page. A page take reservoir of Paris. If the page reserved in London taken until the join is complete, the page will be taken once. But assume that the page reserves not taken to completion. Then the cost will be expensive. Like that. Cost is 500D plus 500 times 1000 T plus S. T is the cost of the read or web page and S is the cost of shipping yard. If the query is not sent to London, should add the cost of the delivery to the query site. Can also do inner nested loop in London. Take the appropriate tableau reserved to London as needed. Delivery to one place. Official refers to London. So the cost will be 1,000 S plus for 1,500 T. We use semi-join cost 3 times 500 plus 1,000. If the result of a very large size, it's better to send to relation result size and then doing a join. Semi-join. Semi-join techniques aim at reducing the number of tuple reserves have been passed. The idea consists of the following steps. If we use semi-join, another project in London projected sellers to join the column and set in to Paris. In Paris, two are joined on the projected seller with reserve. The result of the join is called the reduction of reserve with sellers. Then reduction refers to London. So after we have the result from the Paris, we send the servers to London. In London, sellers joins the refresh that have been reduced. The idea of the semi-join step is to reduce the cost of computing and computational projection, and delivery and shipment projection for full shipping cost reservations. Semi-join, especially if there section on seller and answer are available in London. Next is bloom join. Bloom join technique also intend to reduce the number of tuple reserve has been posted. The idea consists of the following steps. So, in London, bit factor arithmetic of some size k as value of the join column has a range of null to k min 1. If some tuple has indexed to the London to the L, the one bit set to 1. I mean it to the I. The I bit set to 1. So I from null to Q1. Send bit factor to Paris. In Paris, do hasing each tuple reserve in the same way and ignore tuples that perform hasing to null in the bit factor sellers. The result is called the reduction of reserve with sellers. Send bit factor reduction result to London. In London, join sellers with the result of the reduction of server. And the fifth, bit factor delivery costs are cheaper and also more effective. The next subject, query optimization on distributed DBMS. To do query optimization in distributed systems using the cost approach, for example, on our plans, take the cheapest, the same as the centralized optimization. So the difference in the query optimization of distributed system and centralized system, the first is the cost of communication must be considered, and second, where local autonomy must be considered too. And the third is using a new method of distributed chain, like I have explained before. Next subject, change that data on distributed DBMS. To perform the conversion of distributed data, replication transactions can be done by, there are two, synchronous replication and asynchronous replication. In synchronous replication, all copies of the modified relation or fragments must be changed before the modification transaction commits. Data distribution is made transparent to the user. And here is asynchronous replication. Copy of a relationship that is modified only change periodically. A different copy will be out of synchronized. User must be aware of the data distribution. Products currently following this approach. Synchronous replication. There are two basic techniques to ensure the transaction looks the same value with the copy, like this. Voting. The transaction must write the majority of copies to modify an object. To copy should read enough to confuse that seen at least one of the current copy. For example, there are 10 copies, 7 writing to change, and 4 copies for readability. Each copy has a version number. This technique is usually not attractive because reading is not unusual. Read any, write all. Slower reading and reading faster than voting technique. This technique is widely used in synchronous replication. Selection of synchronous replication techniques will determine the place where the setting is locked to. And now we come to the asynchronous replication. Asynchronous replication allows modifying transaction commits before a copy is modified, and readers not only see one copy. Users should be aware that copy out of synchronic for a short period of time. Asynchronous replication technique using two approaches, namely the primary side and peer-to-peer replication. The difference of this technique lies in how many copies that can be changed or the master copy. The difference to technique, the primary and the peer-to-peer. Peer-to-peer replication. So more than one copy of an object can become a master. Change to the master copy to be propaganda to another copy in different ways. If two master copy is changed and there is a conflict, the conflict must be solved. For example, first place, Joe, alter age 35, place 2, change 36. Technique is good to use if a conflict does not occur. For example, every place has a master and a disjoint fragments that have conversion rights owned by one master at one time. Exactly, one copy of a relation is used as a primary or master copy of a copy. Replicas at other places that does not directly alter. So, primary copy publish another place to run fragments to this relation. There are some secondary copies. The main issue is how the conversion of the primary copy to the secondary copy to propaganda. This can be done in two steps. The first step to take alteration made to commit transaction and then apply the change. Exactly, one of copy of relation is designated to the primary or master copy. Replicas at other sites cannot be directly updated. Here's its summary. So between asynchronous and synchronous, where is the better? Where is the difference? Asynchronous, costless, and system more complicated because system use is distributed. I mean, they're still using distributed, of course, but the asynchronous send data every time. So, like, oh no, yeah, asynchronous is so asynchronous will save the data first before send the data to the centralized distribute. And this is efficient because not much cost pay will be paid, like we not like synchronous, it will spend much cost, but the system more simple because the data directly sent after commit, but it's not efficient to use because cost it will be cost much, and it will of course take the time. And nowadays, asynchronous is used more often than synchronous. Data warehousing, an example of replication. The trend now is to build warehouse, a huge data from several places. This allows for complex decision support queries of the data on the entire organization. Warehouse can be seen as an instance of asynchronous replication. Data sources are usually controlled by the DBMS. The DBMS distributed DBMS, I mean. The emphasis is on the data cleaning and removing errors in the manufacture of replication. We will have to discuss more about data warehouse in next meeting. And we have come in the last subject is locking on distributed DBMS. To handle the locking of objects in some places use this way. Centralization, a place to do all the locking and unlocking for all objects. Yes. And the second, primary copy. So unlocking of an object work on where the primary copy of the object. For reading requires access to a locked place where the object is stored as good. And full distributed the last. So it will be locking for a copy made at the place where the copy is stored. It will log in place at the time of writing all objects. Distributed deadlock detection. Every place addressing local wait for graph. Deadlock will occur if the local variable, the local global graph does not form a cycle, as can be seen in the picture shows the global deadlock, like the setup. Change T1 into T2, side B T2 into T1, and global like this. It will be deadlock detection. To detect deadlocks, use three solutions are centralized, which sends all the local graph into one place. Hierarchy is a place to organize into a hierarchy and send to the parent of the local graph hierarchy. So the timeout is to stop the transaction if the wait is too long, like that. Oh, not last. Just before the lesson before it's not last, but here is the last. Distributed query. The recovery process in a distributed DBMS is more complex than the DBMS centralized because of the following reason. The new failure occurs, for example, communication channels and remote sites. If the sub-transaction of a transaction execute different places, all or no one should commit. This requires a commit protocol to deal with such matters. A lock is handled at any place, and as in the centralized DBMS, and action commit protocol is added to lock. So if there will be a failure or an error, it will be handed to lock. To paste commit. Place of origin where the transaction is called a coordinator, while the other places where the transaction executes called subordinates. If a transaction wants to commit, the coordinator sends prepare message to all the subordinates. Subordinates forced to write a port or prepare a log record and send a message to the coordinator, yes or no. If the coordinator receives a message yes, the coordinator first writes a commit log record and sends a commit message to all subordinates. Conversely, forcing write abort log record and send a message abort, subordinate forcing write abort log, rect, or commit based on the given message, and then send the H message to the coordinator. Coordinator writes a log record and after getting out the H message. Two-phase commit. In two-phase commit, there are two forms of communication. The first forwarding letter termination. both initiated by the coordinator. Each side can decide to abort a transaction. Each message is a decision by the sender to ensure that the last decision of failure for the first time. Each message is a decision by the sender to ensure that the last decision of failure for the first time it's stored on a local. So the first it will be on local lock for the it will send to the central. A commit protocol keep a log for a transaction consists of a transaction ID and the ID coordinator. Recording abort or commit by coordinator also include of the ID all subordinates. And if a failure happen, restart it. If you have a commit or abort log record for a transaction T, for example, but do not have the recording end, it must redo or undo. And if displays is the coordinator for T, keep sending commit. Keep sending commit abort to sub until the axe receive. If you prepare log transaction T but does not commit or abort, this place is subordinate to T. Subordinate continue to contact the coordinator to find the status of T. And then write the log record commit or abort redo or undo log record T and write N. If we do not prepare log rec for T unilaterally abort and undo T, the coordinator of this possibility. If yes, subordinates may send a message. If the coordinator for the transaction fails, subordinates who vote yes cannot decide whether to commit or abort T until the coordinate recovers. At the time T is blocked, even if all the subordinates to know each other is sending the available message, then there will be transaction blocked until one of the subordinates could know. If a remote site does not respond during a transaction commit protocol 40, either because the channel is failing or failed. If the place is the coordinate 40, then abort T. If the place is subordinate and did not choose yes, then it must abort T. If the subordinate place and choose yes, it will be blocked until the coordinate not respond. ACK message is used to convey the coordinate that can coordinate to forget a transaction until a latch. Reserve coordinator. It must save the T in the transaction table. If the coordinate fails after sending message prepared but before writing the log record commit or abort, if the coordinator back, then it will abort the transaction. If the sub-transaction is not changed, commit or abort status is irrelevant again. Yeah, here we have come to the exercise, but I will give a really easy for the last recovery. We we may not to consider the I mean we we may not to be really confused because the DBMS nowadays can handle it by the system like that. So we just have to save the recovery, to save the backup like that. And now exercise. So was the advance compared to a distributed DBMS and DBMS centralized? In the there are two: independence of distributed data, so the user does not need to know where the data is located, and It means that a development of the principle of physical and logical data independence. And the second is distributed transactions are atomic. The user can write transactions that access and modify the data in several ways, such as accessing a local transaction. Describe architecture and collaboration client-server. This architecture allows a single query to access many servers, as the client must be able to divide a query into some query to be executed at different places, and then divide the answer to the subquery. After that, this architecture comes for decrease the difference in client-server, where client process is quite complex and overlap with the server, so the difference between the client and the server becomes clear. In carbon server architecture, if a transaction is sent to the DBMS, will be describe how the coordinated activity of different places. So the third question is specifically describe the transaction manager rules at a different place. The concept of atomic distributed transaction. Here is the architecture of collaboration system, where server can send the query to the another server. In this system, there is a set of database server which run local data transactions that cooperate to execute transactions on multiple servers, as in the picture 7.3. So if the server receives a query that requires access to the data on another server, the system evokes a subquery to execute another server and retrieve the result together to incorporate the answer into a query origin. Next, what's the difference between synchronous and asynchronous replication? So asynchronous, it will be costless, system more complicated because system use is distributed, well, and efficient. In asynchronous, the data is saved before it's sent to the central server, so it will be not commit yet. The data is collected, so it will be not directly sent. If we do many transactions, of course, using synchronous, it will be spend much cost system more, because we will send it continuously, like we have update again like that. But in synchronous system is more simple because the data directly sent after commit, not like asynchronous that is more complex. But in synchronous it's not efficient, and that's why nowadays asynchronous is used more often than synchronous. Next, the sixth question. Define as distributed data independence. The user does not need to know where the data is located. So it is the development of the principle of physical and legal data independence. Next, how voting techniques and read one write all implemented in the replication synchronous. So in the voting, transaction must write the majority of copies to modify an object. The copies should read enough to confess that seen at least one of the current copy. For example, there are 10 copies, 7 writing to change, and 4 copies for readability. Each copy has a version number. This technique is usually not attractive because reading is not usual. And read any write all, slower reading and reading faster than voting techniques. This technique is widely used in synchronous replication. Selection of synchronous replication techniques will determine the place where the setting is locked to. Next question. Provide a description of how asynchronous replication is implemented. In particular, explain the intent, capture, and apply. So here is the lock-based capture and procedural capture. Well, in the lock-based capture, the lock or safe recovery is used to generate the change data table or CDT. If this is done, when the last lock is written to disk, must remove the change discontinued subsequent to the transaction. While in the procedural capture, a procedure that automatically raises or triggers working on capture, and the implementation capture with lock-based capture is better because it's cheaper and faster, but have to understand the detail of the property lock. So it will be cheaper and faster, but we have to understand the property of lock, so like that. But in the lock base it will be more expensive and long. The second question, here is the intent capture, log base and procedural capture, and now is the apply. Periodic apply, a process in the secondary place, may change to the CDT, change data table from the primary set and change the copy. The period is defined by a timer or user or application. Replica can be seen as more than a modified relation. If this is the case, replica consists of conversion of the view that rising material as relationship change. Log-based capture plus continuous apply will minimize the delay on propaganda change. Capture while the capture procedure plus application different apply is a flexible way to change the process. So it will combine the capture procedure and apply. 9. What the difference between lock-based capture and procedural for implementation? Procedural capture runs automatically while lock-based runs manually. Procedural capture is cheaper and quicker, but we have to understand the property of lock. The last question, I think. The 10th question, why giving unique names to the more complex object database on the DBMS distributed? Why? Because every partition needs unique global name, which is called relation name. This relation will be fragmented and replicated, and need for the storing recorder where the data saved. That's why we have to give the unique names to every complex object database. Yes, there is our ending of 10 mathing. Thank you guys. See you.